Hi there, welcome to ZTT Tech Talks. Today we're going to discuss the Gina development board. The Gina Dev board has an Atmel AT90 USB 1287 with 128K of flash and 8K of RAM. The Gina is Arduino compatible and has many nice features. First off, this board has an additional 128K of static RAM, providing a lot of data space for the user's application code. It's got a thermocouple amplifier, which is useful for PID control of heating systems, such as espresso machines or solder reflow ovens. It has a micro SD card socket, providing massive data storage for audio and graphics screens. It has an 8 or 16 kHz 12-bit audio subsystem provided by an SPI DAC and a 2-watt audio amplifier. The display is a Nokia 6100 color LCD clone with a resolution of 130 pixels in both the horizontal and vertical directions, with 12-bit or 4096 colors. This is an SPI device. The software on the Gina supports both the Epson and Philips versions of the display controller that are provided by vendors such as SparkFun. The user interface portion of this board features 5 directional navigation push buttons. The Gina also has the option of using a joystick instead. There are 2 mini USB jacks on the board. They are the same connection. One is for internal use and one is for the user interface board for easy external access. The power subsystem starts with a standard 5.5mm power jack, which feeds up to 30 volts to an efficient buck converter, dropping down to 6.5 volts. From here, precision linear regulator provides an accurate 5.00 volts to the microcontroller, facilitating high accuracy analog to digital conversion. There's also a 3.3 volt regulator to provide power to the LCD display and the micro SD card. The microcontroller, RAM, audio subsystem, and thermocouple amplifier run at 5 volts. The micro SD and LCD run at 3.3 volts. The data between these two voltages is translated with a TI bidirectional level shifter. The Gina has a Dallas 1307 real-time clock with a CR2032 battery backup. So on the outside of the board are the Arduino header connectors. Just inside these connectors are the connections for the speaker, the capacitive sensing input, useful for non-contact detection of water reservoir level, and digital I/O for piezo buzzer output if you're so inclined. On the other side of the board, we have 3 discrete outputs with LED indicators, typically used for driving solid-state relays for control of 120 volt power, such as heaters, pumps, and lights. In the middle is a 6-pin Atmel in-system programming header. Down here are the thermocouple screw terminals, and also there are tiny reset and hardware boot buttons on both the main board and the user interface board. The Gina board has been designed with separation and remote mounting of the user interface board in mind. The board can be separated by cutting along this row of vias with a thin Dremel cutting disc or utility knife. When separated, the boards can be connected with low-cost wire or a somewhat more expensive flat flex cable that plugs into this connector here. This completes the hardware overview. The firmware, tools, and Arduino development environment are discussed in separate videos. Thanks for watching.